Parallel axis theorem. Parallel axis theorem. So this is a new theorem. So please read the definition once or twice. Let me see. Let's get a class mode then. Yep. Okay. So let us go back to the statement. So what is parallel axis theorem stating? It states that what? The moment of inertia of a plane area about an axis in the plane of the area is equal to what? The sum of moment of inertia of the plane area about a parallel centroidal axis and the product of the area and the square of the distance between the two parallel axes. So as a whole, the statement looks a little bit complicated, but let us start analyzing this with a simple figure as usual. So I have taken a plane area A. It is lying in one plane. Now I am taking an arbitrary or a reference axis AB such that this plane area and axis AB are lying in the same plane. It may be the XY plane or any other plane, but the only condition is these two are lying in the same plane. Now let us go back to the statement. The moment of inertia of a plane area about an axis in the plane of the area. That means I am trying to here calculate the moment of inertia of this plane area about this axis AB. And what is it given as? It is equal to sum of the moment of inertia of the plane area about a parallel centroidal axis. Parallel centroidal. Centroidal axis means it should pass through the centroid and it should be still parallel to be parallel to the axis AB. That means I should consider the centroid. I'll call G as the centroid of the plane area. Now I should consider an axis passing through the centroid such that it is parallel to AB, and that axis which is passing through the centroid and which is parallel to the axis AB, I will call it as axis GG. Now let us go back to the statement. Moment of inertia of the plane area is equal to the sum of the moment of inertia of the plane area about the parallel centroidal axis. That means I should also calculate the moment of inertia of the plane area about this axis GG, and what else? And it is the sum of this moment of inertia about this axis GG and also what? Product of the area and the square of the distance between the two parallel axes. So that means I should have the area A, which will be known. I should also have the distance between the two parallel axes, which I'll call it as what? YC. So that if you now summarize, what can I write from the axis, so from the theorem? Let AB be the axis in the plane of the area and GG be the centroidal axis parallel to AB. So thus from the above figure you can write what? IAB, moment of inertia of the plane area about an axis in the same plane AB is equal to sum of moment of inertia of the plane area about a parallel centroidal axis. So calculate the moment of inertia of the plane area about the centroidal axis which is parallel to the axis AB plus product of the area and the square of the distance between the two parallels. So the area is nothing but A and the distance between the two axes is nothing but YC. So this is what the statement of parallel axis theorem goes. So read this once or twice, you will definitely be able to get it. But it is also required to prove this. So for which I will take up the proof of parallel axis theorem. Now, as usual, the same thing. Now I have to prove this. What am I going to do? Consider an elemental area A lying at a distance y from the centroidal axis GG, like this. Elemental area A which is lying at a distance y. Now the first moment of the elemental area about axis AB is equal to what now? So this is the elemental area A which is lying at a distance y from the axis GG. But the distance between the axis GG and the parallel centroidal axis AB is what? YC. So what is the first moment now? First moment is nothing but what? Area into the distance, which is distance is nothing but y plus yc. So which is a known concept. Second moment becomes what? First moment multiplied by the same distance. Okay. If I want it for the entire area, what should I do? I should apply the summation on this equation. Now I'll go for some simplification. Y plus yc whole square, a plus b whole square, a square plus b square plus 2ab. That formula I will use. Now I will try to apply the summation on every term in the bracket. That's all. Ay square, sigma a, yc square. Now among these, if you see here, the position of the elemental area can be varied. I can take it here, I can take it higher, anywhere here or anywhere here. So y is a variable, but the distance between the two axes, central axis and axis AB is a constant. That means yc is a constant here. So please note that. So yc is constant. Wherever possible, I'll try to bring it outside. So here y is variable, you can't bring it out. Here yc is constant, I brought it out. Now, if you see here, summation of small elemental areas, sigma A is nothing but what? Capital A. So that is the difference you should see. So y square into. Now, you please observe here. Summation A y square means first moment of the elemental area about the axis GG is nothing but A into y. Second moment becomes what? A y square. If I want the moment of inertia of the entire plane area about axis GG, it is nothing but summation A y square. That means this first term is representing nothing but your IGG only. This first term is representing IGG, and you have A y square. You please observe here what I had supposed to prove. IGG plus A yc square. Already I have got the same, but something extra is still remaining. So this extra cannot be subtracted or cannot be just scratched out. It has to be proved that this is equal to 0. So and ultimately this will become 0. You observe here. What am I going to do is I have divided and multiplied this above term both by a only. So that this term will remain the same. No change has happened by multiplying and dividing it by a. Now you consider sigma ay by a. What is that meaning? So you go back to the definition for centroid. It is nothing but the definition for distance of the centroid. That means it is nothing but y is what? The distance of the centroid from the centroidal axis only. So in the above equation, sigma ay represents what? Excuse me. Represents the distance of the centroid G from the centroidal axis GG. Central axis GG, which is equal to 0. That's all. So distance of the centroid G from central axis is this is 0. So that means this entire term is becoming 0 here. So that if you multiply this 0 by this term, it becomes 0. Ultimately, I am left out with this equation. So this is the proof of parallaxis theorem.